Hey guys, welcome back to another LeetCode video. Today we're going to be doing the daily for March 28th, 2962 count subarrays where max element appears at least k times. So almost like all subarray problems are going to be like sliding window because instead of getting uh ev every subarray like with the double iteration, you could do it like this. So yeah, this is going to be a sliding window solution. And I really liked yesterday, or I'm not sure actually when it was, where I like took a picture and I went on Excalibur. I kind of went over the solution, so that's what I'm gonna do again. So here we have the question, right? So we need to count the amount of subarrays where um the max appears at least two times, right? So first of all, we're gonna go ahead and get the max, right? So for this, 3 is the max, right? So let's go ahead and yeah, I'll just use a thing here. So max equals 3. And so if you guys don't know what subarrays are, basically um it's like this. So it could be this, 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 right? So these are all subarrays of starting from 1 and then starting from 3, this, this, and this, right? So it's just a section of an array basically. And we need to count the max, right? So that appear k times, right? So how could we do this? As I said, we're going to use a sliding window. So, I'm just going to make the window real quick. So here we do left equals 0. And like before, we're going to iterate with right. So right, so it's like for all right in range len nums, right? So this means that right starts for at, let me just make another one, r. And we say left is at 0 right now. Okay, so what we're going to do is we're going to have an element as well that counts how many times we've seen the max, right? So seen max is 0, right? At the start is 0. So this is what we're going to do. We're going to increment, right? No, we're going to check if the current element, which is index 0, is equal to the max. It's not. We increment. This one is. So seen max is now 1. Is that less than k? Is that more than or equal to k? No, it's not. Increment again. Increment again. Now seen max is 2. Right? So that's equal to k, right? So now how many subarrays are there, right? So this is how we're gonna track that. Also, let me just make another variable for final return, right? So this is gonna be the final count of the subarrays, right? So now that right is here, this is what we're gonna do. We're gonna take this left pointer, right? Here, I'll make the left, right? And we're gonna check if it's equal to max. If it is, then we decrement max seen and increment count and increment left, right? So or no, we just decrements max seen. And then now we go to the next one. And so this one is, so we we pop out, or no, we have to increment one more time. And then now, because these are still in the, like, meet the condition, right? There's 1 3 2 3, so it meets the condition. And now that we're here, what we're gonna do is we're gonna add left, the current number where left is, to final return, right? Because that means that from this to this was one subarray, from this to this was another subarray, right? And left is currently at index 2. we add 2 to final max. Let me just add 2, right? So now the condition is not met anymore. And so now we increment right. It's met again. Now we're at left, right? So now this was at index 2. Go here. Go here. Now it's no longer in the range, like 2. Now we add left again to final, right? So that's 1, 2, 3, 4. Actually, I think it's it gets here and then we add it. Yeah, something like this. I'll show you in the solution, but we'll work that out in the solution, but we add it again basically. Yeah, I'm pretty sure we do. Yeah, so it's 0, 1, 2, 3, 4. Yeah, so we add it again when it's here. And now final return is 4 plus 2, which is 6. So that's really the idea here. And let's see. Yep, and you can see the output is 6, right? So I'm like, if you know sliding windows, it's pretty simple. Just the big idea is that you add left to the final. So I mean, let's go ahead and find this out. Let's go ahead and solve this. So m is going to be max, okay? Equal to the max of nums, right? So we can already go and get that. And then scene max is 0 because we haven't seen it yet. We haven't done anything. The final count is 0 and left is 0, right? And like before here, okay, let me connect. You can see we're gonna have to do the for I in range whatever, right? So go ahead and do that. For R in range len nums, right? So as I said before, we're gonna check if the current element is the max. So if nums at R equal max or not max, we do m. Then scene max plus equal 1. And then while oh my bad, scene max greater than or equal to k. So now we just decrement, like move left over. So if nums at left equal m, max or scene max minus equal 1, and increment left as well, L plus equal 1. And then here we just do count plus equal left. That's about it. And now we just return count. What is it? Okay, I spelled something wrong. Perfect. And let's submit. Okay, and it's pretty fast. This person probably did the same thing as us. Okay, yeah, they did the same thing as us. Well, they did equal, but oh yeah. I mean, they could do equals. We can do equals as well. It doesn't really matter. And now let's do a time complexity analysis, right? So, I mean, finding the max, you'd have to iterate through all of it, right? So that's n. This is n time, right? And one space. And all of these are one space, right? Over one space. And now this loop is going to be n. This is going to be O of 1. This is basically going to be O of 1 actually, because whenever well, it's not going to be O of 1, but it's still going to be in the magnitude of O of n. Like this whole thing is going to be O of n, even though this is a while loop, because It doesn't iterate through the whole array again for it to be like n squared or something. And that's about it. So overall, this is gonna be let me just n time and one space, right? And just to get that 99, let's run it again. Well, okay, close. It doesn't matter. Anyways, make sure to like and subscribe. Come back tomorrow for another video.